Hi guys, today's lesson is about factoring and we're going to learn how to factor monomials and binomials today. You already know a little bit about factoring. Remember to give two factors. If we have 15, then it's 3 times 5. 5, make sure you give 1 times 5. If it's x squared, then it's x times x. If it's just x, then it's 1 times x. And if it's negative x, what do you think it is? It's negative 1 times x. So when we have to factor just one term, you already know how to break them up into prime factors. So the question will ask you to factor a term. Make sure you list each term and make sure they are prime factors. When you have two terms, then we can use two methods. And this depends on which question you are getting. So let's try reverse distribution. You already know how to do this a little bit. You know that factoring is the opposite of distribution. So when there are two terms, such as this, there is a common factor, 3x, and so it's 3x times 5x plus 6. And this actually gives us two factors. The two factors are 3x and 5x plus 6. Look for the GCF in the coefficient and the variables. So when there is a difference of squares, this is something again we've done in the previous lessons. When you multiply the sum and a difference of the same number, these two other factors on the left, you end up with a product of a squared minus b squared. And so if a squared minus b squared is given and you have to find the factors, then it's a plus b times a minus b. So let's try this out. So it turns out that 9 and x squared and y squared, they're all perfect squares, and so is 16 and b to the 4th power. So it's really 3xy squared minus 4b squared. So we're going to list it as two factors, and the two factors are 3xy plus 4b minus 4b. If you find this difficult to understand, make sure you relate it to what is given on the top. The rule is on the top. Here again, 81 is a perfect square, 1 is a perfect square, and p to the 6th is also a perfect square. And so the answers are, and this really should have been 3 and 3 over here. I think I forgot to put it down here. So these are p to the 3rd and p to the 3rd. Moving on. Let's see if you can try these. Pause the video and see if you can get the correct answers. And the answer is, the first one is a difference, but it is not a difference of perfect squares, so be very careful. The second one is a difference of perfect squares. And sometimes you may have to factor in a monomial first. Here, 24 and 6, they're not perfect squares, even though g squared is, but there is a common factor, which is 6. And so inside we get 4g squared minus 1, which are, each term is a perfect square inside. So we can factor it a little further, and it becomes 6 times 2g plus 1 and 2g minus 1. See if you can try this. I know you can't see it. I'm going to move my picture here. And it's 12p squared minus 48, which if you factor out what is common, which is 12, then p squared minus 4 is a difference of squares. And so it becomes 12 times p plus 2 times p minus 2. And I want you to try this. This is a little bit more challenging. So let's say you see, oh, these are perfect squares. Let me factor it out. And it becomes like so. But then the second one is still a difference of squares. This one is still a difference of squares. This is like taking 12 and you have factored out 3 and 4, but the 4 needs to be factored further. So same way, the x squared minus y squared needs to be factored further because it is a difference of squares. And so you'll keep the first factor, and then the second factor becomes x plus y times x minus y. And that is it. I'll see you soon. Goodbye.